Next up, we're going to look at solving linear applications. So we get into word problems, which you can see all sorts of types of problems here. This is kind of the hardest thing to prep you specifically for the test because you'll get a different word problem. They're all a little bit different, but they're all linear applications. So ultimately, you're either given the equation of a line that has some sort of real-world context, or you're going to find the equation of the line in the real-world context, and then maybe interpret the slope or the y-intercept, or evaluate the function, or solve for x, or whatever the variable is. We're going to do a couple of those things, actually almost all of those things on this problem here. The two I picked don't explicitly ask me to find the equation, but I can't do it without finding the equation. So these problems, both of these problems use this information. A town's population has been increasing at a constant rate. So the town's population has been increasing at a constant rate. In 2010, the population was 46,020. By 2012, the population had increased to 52,070. Assume this trend continues. So we're going to predict the population in 2016 by finding a linear model, and then identify the year in which the population will reach 75,000 according to that model. So the first thing I have to do is find the equation. So if I look at it, I'm really given 2 points here. If we use the actual years, we would have 2010, 46,020, and then 2012, 52,070. And we could use the years, but the numbers will get really large. It's pretty common to set a base year here. Since our first number occurs in 2010, we're going to let x equals 0 be 2010, and then measure from 2010. So our first point is going to be 0, 46,020. And then my next point in 2012, that's 2 years later, so it'll be 2, our population, 52,070. Okay. So that's really common when you're doing years like this, to pick one year to be 0 and then measure from that. So 2 is 2 years after 2010, so 2012. When we look at 2016, that'll be x equals 6. But first we need to find the line. So now, once we get to here, we have 2 points, we find the line. The numbers are kind of large, but it's the same type of problem. We're going to find the slope. So do difference in y values, 52,070 minus 46,020 divided by the difference in the x's, which is 2. Compute that out. I got 6,050 divided by 2, which is 3,025. I went ahead and put the units here, so if you were asked about interpretation, slope, you always have your y's over x's. Your units would be whatever the units are on y over the units on x, which in this case, these are people per year. So the slope tells me how fast it's growing. It's growing by about 3,025 people per year. So that's the slope I need for my line. To find the equation, we need at least one more point, and we could plug in to the point slope form and find the line. In particular, though, we have the value at 0. The y-intercept is going to be 46,020. So my equation would just be y equals 3,025x plus 46,020. I went ahead and showed here I could still use with either of the 2 points the point slope formula if I wanted to and plug in. We know the slope is 3,025, and then I went ahead and plugged in 0 for x, 46,020 for the y value. You solve that, it simplifies pretty easily there. You get 3,025x and then plus 0, and then you add over and get your b value is the value at 0, 46,020. In context, the y-intercept is always the value when x equals 0, so in this case it gives us the population in 2010, which we were actually given in the problem. So we have our equation, we have our formula there. We can find the answers to questions 11 and 12 now. So question 11, we just have to plug in and evaluate. Predict the population in 2016. So we're using x equals 0 to be 2010, so 2016 would be x equals 6. So we just plug that in. So I did that. I got 3,025 times 6 plus 46,020, and I wound up with 64,170 people. And then on number 12, we want to find the x value. What year will give us a y value of 75,000? So we have to solve the linear equation. So I just subtracted the 46,020 from both sides, got 28,980 equals 3,025x. Divide both sides by 3,025, and I got about 9.58 something. So add that to 2010, it's sometime in 2009. So sometime during the year 2009, the population will cross over 75,000. And after linear functions, we moved on to quadratics. So the next section was all about solving quadratics. We did them several different ways, and I've listed in the topics you want to be able to solve by factoring. Here's one where the coefficient in the front is not a 1, which always makes it a little bit tougher when you factor, but a lot of people still do the sort of a guess and check method. I've got the answer here, but if you think about it, 2x squared would have to be 2x times x, and then I can only break 5 apart into 1 times 5, but I have to figure out the right combination, and you just have to kind of go through those there till you find where the middle term works out. If we do 2x plus 1 times x minus 5, that would definitely give us the 2x squared and the minus 5 on the outside terms. But on the inside, I get 1x, and negative 10x would give me negative 9x. So that's how it'll factor, and you can figure that out mentally in your head there thinking about it. I also showed in class this AC method, which is similar but turns it into a factor by grouping problem, which a lot of people like. I like it. As I mentioned in class, there's no guess and check of trying all these combinations. So for the AC method, you start by looking at A times C, 2 times negative 5 in this case, which is negative 10. And then I look at factors of that, numbers that multiply to give me negative 10 and add to give me the negative 9 in the middle. And negative 10 and 1's the combination that'll do that. Negative 10 times 1 is negative 10, but negative 10 plus 1 is negative 9. And I use those two numbers to replace the negative 9x. So we turn 2x squared minus 9x minus 5 into 2x squared minus 10x plus x. I've replaced minus 9x with negative 10x plus x. That gives me 4 terms, and I can then do factor by grouping. I look at the first 2 terms, I group those together and pull out the common factor of 2x, which gives me 2x times x minus 5. If you divide the 2x squared minus 10x by 2x, you're left with x minus 5. When you pull out the greatest common factor, which is just a 1 here, you need these two pieces to match, so we have to think of it as factoring a 1 out. We get x minus 5, x minus 5. You factor that out, you've got x minus 5 as one of your terms, and you're left with 2x plus 1 as the other term. So however you do it, you wind up with the factors there, 2x plus 1 times x minus 5, and then just set each of those equal to 0 and solve, and you'll get x equals negative 1/2 and x equals 5. We also solved with the quadratic formula, so make sure you memorize the quadratic formula. Negative b plus or minus square root of b squared minus 4ac over 2a. That's the quadratic formula where you have ax squared plus bx plus c equals 0. And then you just identify your a, b, and c and plug them in. So number 42 here is x squared plus 4x plus 2 equals 0. So we have a, the coefficient of x squared is 1, b, the coefficient of x is 4, and c, the constant is 2. So my first step when I'm showing the quadratic formula is just plug all that in. So negative b will be negative 4 plus or minus the square root of 4 squared minus 4ac will be 4 times 1 times 2 over 2a, 2 times 1. And then we can simplify a little bit. We've got our negative b and our 2a there, and then I would do the discriminant part, the b squared minus 4ac. You get 16 minus 8, which is 8. And I've told you on the test you could leave this. If it's a perfect square, compute it, get your nice answers. If it's not, square root of 8 is not a perfect square, you could leave it like this. It will simplify a good bit. I'm going to go ahead and do that, but to save you time on the test, you don't have to do this simplification step here. But 8 is 4 times 2. You can rewrite the square root of 8. You can take out the square root of 4 and write it as 2 square root of 2. And then you can actually divide both pieces by 2 and get negative 2 plus or minus square root of 2 would be the nice simplified answers. Okay, do one more on this video. Solve equations with rational exponents. So you have exponents in them that are fractions. Okay, so the technique there, if you've got this term, if you've got something with a rational exponent, a number on the other side, take the exponent, flip it, and raise both sides to that. So I'm going to take the 2/3 and flip it, excuse me, and get 3/2 and raise both sides to the 3/2 power. On one side it's going to cancel and just give me what was inside the power, the x plus 1. You notice I have a plus or minus here. Whenever you raise something to a fractional power, you're taking a root. When you apply a power, the one on top is like your regular power, the one on the bottom is a root. 1 over n is the nth root. So here I'm actually taking the square root of both sides. So if the one on the bottom is even, you're taking an even root, you have to do plus or minus. When it's odd, you just get the one single answer. But in this case, we're cubing both sides and we're taking the square root, so we do get the plus or minus. So left-hand side, again, is easy. I've got my power to the reciprocal. I multiply those. They're going to cancel, and I just get the x plus 1. The other side, 4 to the 3rd is 64. Square root of that is 8. So I get plus or minus 8, which gives me my two answers. I have x is negative 1 plus 8, and x is negative 1 minus 8, which gives me 7 and negative 9.